Hey YouTube, Booth Dog here. Another week of learning and teaching like this. Hope we're kind of getting used to it. I'm definitely settled into a routine. Just want to remind you that I'm getting a lot of great questions from your exit tickets each day. Please remember that I do try to answer those in the next day's Google Meet. So if you want answers to those questions, please, I know it's not always possible, but try to join that Google Meet. And if you have a question you need a desperate answer to, then email me just to make sure that I get an answer to you, okay? Before we jump into today's lesson, we do have another promotion today. Today's video is sponsored by paper, okay? Yes, real paper. I'm a firm believer in doing math on paper, of course, with wooden pencils, not that mechanical trash. Anyway, let's turn things over to Mr. Boothman, and let's get started. Happy Monday. Some announcements to start our day, start our week, really. Your exit ticket today will be to submit a question you have from today's lesson. That will be due by midnight tonight. Today, we'll add the last new concept to our notes here in 10.5, and then we'll be done with new content for the year. I know, very, very sad, I know. I guess some of you are probably happy, Maddie. But anyway, 10.5, continued. So again, this is going into your notes. The last thing that you will see or potentially see on this year's AP exam are special types of series. All right. Now, these are known as P-series. So P-series look like this, where P is some constant. So in this case, there's three possibilities. The first, when this P constant is greater than 1, then our series converges. When P is greater than 1, our series converges. So what does that kind of series look like? So for example, let's say P equals 2. If P equals 2, then we have 1 over, now n is 1, so 1 squared, plus 1 over 2 squared, plus 1 over 3 squared, and so on to infinity. Okay. In this case, these fractions are getting very, 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 very small. So as we keep going, okay, just conceptually speaking, it should make sense that this series will ultimately converge upon a real number. Of course, to formally prove that, it requires a little more effort. In fact, it really would require a test that we aren't really going to talk about. It's called the integral test. So that is another test for convergence of a series. And for now, I really just want to expose you to these special types of series, so you know that they exist, you know what they're called, you're familiar with at least these rules, okay? The second case, when P is less than 1, then our series diverges. So, for example, let's suppose P is 1/2. Okay. Then we have 1 over 1 to the 1/2 plus 1 over 2 to the 1/2 plus 1 over 3 to the 1/2. Okay. In this case, our series will diverge. Just conceptually take a second, try to reason through that yourself. Again, a formal proof would be required, but that's not something we're looking at here. And the very last case we have, what happens when P equals 1? Well, in that case, we just have the series 1 over n. And this series diverges. And this particular series right here has a very special name. It is known as the harmonic series. Okay, so harmonic, that's kind of a music term. In fact, it is a music term, and it is named after this idea from music theory. Okay, if you know anything about harmonics and overtones, then you know that they are formed by these fractions of a fundamental pitch. And so you end up with numbers like this. And since p equals 1, if we were to write out this series, we would have 1 over 1 plus 1 over 2 plus 1 over 3, and so on. So we see the same numbers that show up in our harmonics in music, okay, which is why we've named this series the harmonic series. And I'm telling you that this series will diverge. The proof of this series diverging is actually quite interesting. It requires yet another convergence test that we're not going to discuss. It is a pretty straightforward idea though, so if you're interested at all, come to our Google Meet today. I'm more than happy to go through that proof of why this harmonic series diverges. But the fact that the harmonic series diverges is one of the most famous divergent series in math. Because really, our denominators are getting smaller. It feels as if that the series should eventually reach a point where we're adding 0 to our ultimate sum. But again, it's quite interesting. So come to our Google Meet if you would like to see more about that. Otherwise, this is all that I wanted to talk about today. I wanted to include these so you have this in your notes, so you're at least familiar with these terms, what they are, and when they converge and diverge. Okay. For your work today, for your practice, okay, it won't really have too many questions about p-series and harmonic series, but they are continued practice for 10.5 in general. So I would like you to work on the 5th page of this mastery sheet. So that's looking at this AP exam prep. So that 1 and 2, those are pretty good thinking questions. Number 2 is a little more straightforward. And then that FRQ at the bottom of that page. Okay, so you're fully capable of answering all of these questions. I have every confidence in you. Tomorrow we will look at page 6, and then pages 5 and 6 will be due by the end of tomorrow. But for today, focus on page 5. Send me your questions, join our Google Meet, and answer that exit ticket by midnight tonight. All right, let me know if you have any questions. Otherwise, have a good day. Thanks, Boothman. What a great guy. Please make sure to reach out to me with any questions you might have. Otherwise, I'll see you tomorrow.